We're going to work further here on how to solve systems of equations by substitution. So I have a system here of x equals 1 plus y, and my second equation is 3x plus y equals 3. So you'll notice that this example is different than the previous ones because I don't have both equations as a y equals. What I have instead is one equation that's been solved for a variable and the other one has not. And what I mean by solved for a variable is I mean that I have just a 1 times a variable, or just a variable, being equal to an expression. Okay, so what we do with this is just like what we were doing with the examples previously. We have x being equal to 1 plus y. Since x is equal to 1 plus y, we're going to take that expression of 1 plus y and replace the x in the second equation with it. So here's what this is going to look like. We're going to sub equation 1 into equation number 2. And we start with equation 2, which is 3 times the x. We're going to replace that x with the expression of 1 plus y. And then we still have the plus y from the original equation, and that was equal to 3. And there we go, that's equal to 3. So now we're going to follow what we did with solving equations when we had brackets. We're going to need to expand that 3 through the bracket, and when we expand, what we're meaning is that we're multiplying. So 3 times 1 is 3. 3 times y will be plus 3y, and then we still have this plus y on the end, and that's equal to 3. Now, our next step when we're solving equations like this is to collect our like terms. So I have 3 y's plus 1 more y. That's going to equal 4 y's. Now at this point, I can start to isolate to get y all by itself. There are two things keeping y from being alone here. The 4, which is multiplying y, but then we also have this plus 3 on the front. So to undo that plus 3, we're going to subtract 3. And remember, we're always solving in the reverse order of BEDMAS. BEDMAS is just to calculate something, whereas solving, we need to do SAM/DEB. So the plus 3 and the minus 3 go away, and what we're left with is 4 y's being equal to, 3 take away 3 ends up being 0. So 4y is equal to 0. Now we're going to undo the times by 4 by dividing both sides by 4. And if you do 0 divided by any number, the answer will be 0. So we get that the y-coordinate of our intersection point is 0. Now what we need to do is find the x-coordinate. So I'm going to take that value of 0 and we're going to sub that back into the first equation, into equation number 1, which was that x is equal to 1 plus y. And since the y is 0, x will be equal to 1 plus 0, which ends up equaling 1. So these two lines should intersect at the point 1, 0, because x comes before y. So our solution, or the intersection point, I'm not sure what I'm doing that I keep moving the screen. The solution is, the x-coordinate is 1, it goes first, and then the y-coordinate is 0, it goes second in our ordered pair. So that's our first example. Let's try the next one. So you know, as we do examples, I usually add things on as we go. My next example is the equation 4x take away 7y is equal to 20. And my second equation is x take away 3y equals 10. So equation number 1 and equation number 2. Now you'll notice this time I don't have y equals or x equals. The x's and y's are all embedded with other things with them on that side of the equation. So the x and the y here have the 4 and the 7, and they're together on that side of the equal sign. My next equation has a 1x, a minus 3y together on that side of the equation. So I don't have an x equals or a y equals yet. So here's what happens, is we're going to make that happen. What we need to do is solve one of these two equations, or rearrange one of these two equations, to get x or y by itself. Now there is a smart choice here, and you really want to pay attention to this because I know most of you would rather not take the hard way out. You'd rather do things the easier way so that things aren't as difficult as they need to be. What you really want to do is look for a coefficient of 1 on one of the variables. You want to look for a coefficient. Look for a coefficient. A coefficient is a number in front of a variable. Coefficient of 1 on one of the variables. Now in this case, there is only one variable that has a coefficient of 1. And if we don't, then we do have to look for maybe the smallest number we can. Ideally it's a 2 or something that when you divide it out, you don't end up with crazy decimal numbers to work with. So in this case, I have a 1 in front of the x in equation number 2. So what I'm going to do is I'm going to rearrange equation 2, for x. We're going to solve it for x. We're going to get the x all by itself. So we have 1x minus 3y equaling 10. That's the original equation. I want to get x all by itself. So the first thing I'm going to do to get the x by itself is undo this minus 3y here. Okay, and to undo a minus 3y, we're going to add 3y. That's the opposite. So I'm adding 3y to both sides. That undoes this piece, leaving me with just a 1x, or just x, being equal to 10 plus 3y. So now I have an expression that I can use for x. X is equal to this 10 plus 3y. And this came from equation number 2. So what we need to do, since this came from equation 2, we have to sub this into the other equation. It has to go into the opposite equation. So we're going to take this expression where we have x equals 10 plus 3y, and we're going to sub that into equation 1. It has to be, these have to be not the same equation. All right, so sub it into equation 1. Equation 1 was 4x minus 7y equals 20. And where I have the x here, I'm going to put this expression. So we will have 4 times the 10 plus 3y minus 7y equals 20. So I've just replaced the x with the expression 10 plus 3y. Now we're going to expand, like we learned before when we were solving equations. 4 times 10 is 40. 4 times 3 is 12 with a y. Minus 7y equals 20. So everything else is staying the same. I'm looking for like terms that I can put together, which I have here. I have positive 12y's, but then I'm taking away 7y's. That's going to leave me with 5y's. So I still have the 40 plus, and then we have 5y's equaling 20. Now at this point we still need to, we can start solving for the y. We want to get the y by itself. We have a 5 that's multiplying it, but then we have this plus 40. So to undo the plus 40, we're going to subtract 40. Remember, we're doing Sam, Deb, Bedmas backwards. We're minusing 40 from both sides. We're left with positive 5y on the left side of the equal sign, or just 5y. And then 20 take away 40 is negative 20. Now to get y by itself, it's being multiplied by 5. So we're going to divide by 5 on both sides. So we get 1y, or just y, and then negative 20 divided by 5 will be a negative, and 4. So we have the y-coordinate of our intersection point, but we're not done quite yet. We don't have the x-coordinate yet, so at this point, I'm just going to take this up here, we're going to take that value of y, sub, and we're going to substitute it back into that equation that we solved for x. So I'll underline it in yellow, right here we had x being equal to 10 plus 3y. We're going to sub that back into the y equals negative 4 into that equation. So we're subbing that into x equals 10 plus 3y. Okay, so x will be equal to 10 plus 3 times y, or 3 times negative 4, since y is negative 4, which is equal to 10, and then we're going to add 3 times negative 4, which is negative 12. Adding negative 12 is the same as just subtracting 12. And 10 take away 12 is negative 2. So now we have the x-coordinate of our intersection point, or our solution. So therefore the solution is, and the intersection point, x comes before y in the alphabet, the x has to come before y in the statement of the ordered pair. Even though we found y first, the x always goes before the y. It doesn't matter what order you found each variable. All right, one more example here, but I'm going to do that on the next video. If you want to try this one to get started, the next example is going to be 2x minus 3y equals 6, and the other equation is 2x minus y equals 7. Okay, those are the two equations for our third example. If you want to try that one on your own following these steps, and then I will take that up on the next video.